Okay. Again, there was no text that went out that says, here's how the class is doing, so don't bother asking me about the grades if I haven't done that yet. Okay? When they go in, I'll text you right away. So right now, it's just jump back in. Like I said, the last 4 weeks of the school year are on the calendar on the back. And we only got 3 sections left in what we are supposed to cover this year. Okay, so after this week, or 2 days next week, I'm going to talk to Jameson, figure out what he wants folks doing, because he's got most of the algebra ones. I think he's got 3 of them. Who's got the other ones? McCreary, I think? Yeah. So we'll go talk to them, see what they want you starting at. Our curriculum right now has you just picking up at Chapter 7. But I want to double check because, again, we have new curriculum next year and everything's kind of wonky. Boy, Algebra Half next year is in for, they're in for a hurt. But other than that, those 2 days next week, it's all up there. You'll have another quiz 2 weeks from today. That will be your last one. That would be probably your last day to turn in all your daily work and stuff. If you get anything else done in the week after that and want to come have a chat with me about turning in some late stuff, I'm okay with that, but you're going to have a talk, not just show up and dump a notebook on my counter, okay? And then we will have 3 days of review in class for finals. You're the last final. Again, I just found out I'm gone during the 4th block on the 25th, but on the 26th, you only have to be here for 2 tests, white 1, white 2, during blocks 2 and 3 respectively. If you're one of those kids who says, nah, I just don't want to be here on Friday, I don't know, maybe you've got like academic life skills during white 3 or something like that, where you just don't have to show up. If you want to reschedule your final for this class for that Thursday, you go right ahead. You just got to talk to me ahead of time so I know what's up. Okay? Whoa, we're almost there. Words, figure it out. Argue with your neighbor. You just did a whole bunch of system stuff, and today is just an extension of that. If today is basically, y'all remember the stuff we just did and the word problems that you didn't like? Today is only word problems. If you knew how to do the word problems from the last 3 lessons, you're good. So, can you figure this out? Because this very well could have been a question on your test. What do you think? Hmm? When will they be the same height? So they're both going to burn down at different rates. Oh. Hmm. See, the best fidgets make noise, but those are also the ones that annoy the living crap out of people. Okay, argue that with a neighbor if you want to. I don't care. Just, what do you think? There's a magic word in there that basically tells you what's up. When will they be the same height? Can you make an equation out of it? Basically, if you can do this from the get-go today, you're set. Today is just review and practice with words. Now remember that magic slide that we had with all three of our linear forms, how they show up in word problems? Double check the calculators before you travel all the way back to your seat. Sounds like they're finally dying. So I will now recharge them for the second time this semester. Those things last forever. What's the magic word in here? Rate. That was one of our forms. Remember, in terms of words, this is y equals rate x plus start. So when they just straight up tell me, here's the rate, well, there you go. Taller candle burns at a rate of 1.15 inches per hour, shorter at a rate of 0.75 inches per hour. How many hours after will they be the same height? Explain your reasoning. But you need to be careful here. Yeah, they both start at 9 and 7 respectively, but what are the actual rates? Close. Negative. Why are the rates negative? Burning down, decreasing, getting smaller. So I have to be careful that the height of this one is going to be 9 inches minus 1.15x. The height of this one is 7 minus 0.75x. Okay, we just did a whole bunch of different ways. We did graphing, substitution, elimination. Which way does this look like it's just set up for? Should I do elimination or substitution with this? You could eliminate by just subtracting one from the other, right? I would be leery of elimination because how many of us are A, going to forget to subtract all three terms? Like, we'll subtract this one, maybe subtract that one, accidentally not subtract that one because it's really adding. B, how many of us, when we get y minus y, and I see this year after year, since those cancel, I've got kids who will say 0.45x or negative 0.45x equals 2. Even though it's 0 equals 2 minus 0.45x. Or wait, no, it's 0.40. All right. There's so many kids that when they see this zero out, they'll just kind of move the equal sign because they're used to there being something on both sides. What's left on this side if I do that? 0, and 0 is a number. And because of that, that's why I would probably go for substitution, because this one has a lot of common pitfalls, things that I see kids goof up. But if you can turn words into math, math into words, that's all today's about. So do you remember the mathematical linear Holy Trinity? Okay, we've done it twice now. We did it in chapter 6. We did it when we finished off standard form in chapter 5. So first, slope-intercept form. Y equals mx plus b. You know what? This would be really good review for that final too. We are now what? 1, 2, 3 and change. You're like 3.5 weeks away. In terms of the function itself and how I graph it, it's going to be y is, remember, rise over run, x plus my starting value was always my y-intercept, and it's at 0, b. So we got that for graphing, but for words, rate x plus start, which we just saw. When we say start, it's an initial amount. You have to pay $120 to get into Disneyland, and then every ride thereafter is $10. Okay. Well, I have to do this no matter what. Then things. Okay. How many of you have had to, your folks have had to call a service tech over? Your heater crapped out. Needing a plumber. Needing someone to patch something on your roof. We live at the northern edge of the Black Hills. Wind and hail. If you got to pay someone to come out there, and then it's so much per hour while they're working, that's a good example of this. It's $50 for a service call, $65 an hour. It's $50 to even get out to your house and unpack their stuff and come in. And then they start charging you. Okay. After slope intercept, less frequently used, point slope. Now, point slope is real good for, point slope's really good for starting the line. I know that most of you preferred to dump in a y, m, and x, go find b. But if you can dump everything into one spot and then just rearrange it, it's actually the way the majority of books are written. That's y minus y1 is m times x minus x1. And maybe it would help next to these to have this is a number, this is a number, this is a number, this is a number, this is a number. Because you always want the y and the x there. That's what makes it an equation. A variable equation. So these ones, well, I don't think I even need to say that again. It's just like that stuff again. It's just instead of having a starting point, they'll just give me a coordinate. The word part of it, that's where we really want. Y minus, and it'll give me some output, is rate x minus some input. Okay, a prime example of that one would be a 5-hour service call costs $380. The tech charges $80 to show up to any location. Well, that would be a starting amount and an input-output. That ain't right. What if it was, it's $380 for a service call and then they charge $60 an hour? Well, now I have a rate. Now I know if I input this many hours, I get out that much cost of bill. We ran across these in one of our practice worksheets back in chapter 5. Standard form. They really liked these ones for elimination problems. AX plus BY equals C. Now those ones, to graph them, if I plugged in a 0 for Y, I get an x-intercept of C over A. If I plug in a 0 for X, I get a y-intercept of C over B. And those give me quick graphs. divide this, poke dot, connect dots. Done. Very little algebraic manipulation, just 2 quick division problems. In terms of words, we had a rate for the first thing, a rate for the second thing, and y'all just took a test on Thursday. Oh, don't forget my Y. What was at the end of this? What was the thing that set it apart? Totals. Okay. Another thing that helped with our standard form is whatever the things they're talking about are, whatever the labels or units on them, it tells you which equations go together. If I say something about money, all the stuff about money needs to go in the same equation. What was an example? What was the one from the quiz? It was like chickens and pigs, how many heads and feet there are? Something, I don't know, I just pulled it out of an old book. Well, I'm talking about chickens, I'm talking about pigs. That's my X and Y. And then they say they counted this many heads, they counted this many legs. Well, all the stuff about heads should be in the same because they gave me a total of heads. They said this many legs. I should put all the leg stuff in one equation because that's the label for it. If you've got these 3, you are good to go. Oh, there's a number, there's a number, there's a number. There we go. Now it's just a matter of putting it to work. Okay? So this is a separate section because this is something that we just need practice with. One of the most commonly used places for this is break-even points. They want to know, when does this equal that? Usually, when does my income equal my expense? Because after that point, I'm just making money. Okay, a good number of you probably, how long has she been at the high school now? Y'all at least know who McCreary is, right? No? Down there by the teacher lounge. Young, looks like she could go to high school. She was my student teacher years ago. And we did 3 variable systems with these in Algebra 2. And after we went through that lesson, she's like, oh, hey, wait a second. Just had this big aha look on her face. Came back about a week later and said, I showed this to my brother who has a graphic arts business. I think he makes t-shirts or something. He started using this at his place of business to literally maximize his profits. I should focus on this instead of this. I should make this many of thing instead of that many of thing because it will make me more money. Break-even point is when I have 2 equations where it's income expenses. This is where everything's great. I have broke even. But after that, my income is greater. So that's where I want to be. Example. Make hats. I don't know why you're just going to make hats, but you're going to make hats. I don't know too many fashion designers who are going to make hats for $12.50, but that's what happens when you get a math textbook, right? Material for the hat costs $5.50. The hat costs $12.50 a piece. They're going to spend $1,400 on advertising. How many hats must they sell in order to break even? So I got 2 equations. Do you see where they are? Think about income and expenses. Okay, material, is that an expense or an income? It's an expense. They sell for $12.50 each. Is that an income or an expense? Income. They're going to spend $1,400 on advertising. Expense. So make your 2 equations. One of them is income, one of them is expense. So income. $12.50 per hat. Don't overthink it. That was an expense, right? You're right, the 1250x, but that's it. That's the only thing that was income.
And the next one would be 550x plus.
Well, it's going to be income and expenses. They're both expense, so they're both going to go in the same equation. Which one do you got to pay no matter what? And which one changes? Do you got to pay $550 no matter what, and the $1,400 changes? Or do you have to pay $1,400 no matter what, and the $550 is what's changing? Okay, so that's a starting amount, right? So I know I have to start with $1,400 of expenses, and don't your expenses still increase the more hats you make? Yeah. So it is still a positive slope thing. It is still $550 per hat. We just kind of assumed that. Maybe we should have written that off to the side and said X is the number of hats and Y is the number of dollars. Okay. So this is my income, this is my expenses. If I were to look at that as a graph, just a sketch of it, okay, 1,400 plus 550x versus I have made no money yet, but the rate is much bigger. At a certain point, I will have made enough money to cover my expenses, and now I'm just rolling in it. So, what do you think? Solve by substitution or elimination?
Substitution.
If they just said y is stuff, replacing y with stuff is pretty easy. So if y is this stuff, then replace y with this stuff. 1250x is 550x plus 1400. Play the Who's Lonely game. Who's all by themselves, sad and alone, trolling people on Reddit. Okay. You bring him a date. Bring that 550 over. Zero out. And say I got 1400 is 7x. Divide. Now you're not out of the woods yet. X is 200, but what does that mean? 200 hats. How many hats must they design to break even? Well, did I answer the question?
No, because you have to get 200 to go there.
I know that if I make 200 hats, I'm going to break even. Do I know where I'm going to break even? How much money I have to make to break even? I know it's done with 200 hats. I have answered the question. But the smart thing now would be to plug it back in and just make sure y is 1250 by 200 hats. So what's that? 2400 plus another 1200, 3600? No, that's a decimal place. That's a decimal place. 2400 and then 0.5 half 100, 2500?
Yes.
Right?
Yes, 2500.
Someone check it. Okay. Yeah. So how many hats must they sell to break even? We got to know that it's not enough to just say this. Yeah, I did answer the question, but maybe say at 200 hats, my break-even point is 2,500 bucks. So I needed to sell this many hats to get to 2,500 because that's where I'm now making money. Everything after that, I'm making $7 a hat because that's the difference between cost of materials. I've already paid off my advertising, cost of materials, and price. Okay? Setup almost identical. That's what today is just practicing the word stuff. We hate words, so we have to practice words. You don't get better at things by avoiding them. They say the words right there. Initial costs. Initial. Starting. Okay? They're serving it up to you underhand. It's written the same way. You just got to write it and solve it. Same thing. Expenses, income. Which of those things belong to expenses? Which of those things belong to income? Did you label your variables? What is X? What is Y? Okay. Use a calculator. Double check. Use a real calculator and double check. And again, check the calculators before you walk back to your seats because they're finally dying on us. Not all of them. Oh, they can have the battery warning on there and still go for another 3 weeks. Yeah, these things are awesome. First thing I do is label my variables. How many copies must be sold to break even? So they're telling me I'm going to sell copies of my book. You can either use C for copies, you can just say number of books, whatever it is. And again, money, everything about money. Then write your two equations. Expenses and income. What up there do you have to pay? What is he paying? Okay. His costs are this, and it says initial cost. So rate X plus start. Start is initial. Initial is 864. Okay, now what about the rest of it? Which one's a expense, which one's a income? It even says, well, it says binding and packaging costs. I suppose you kind of have to know that that's part of the process if you don't know what those words are or if you've never heard them in that context. Might be a little iffy. The price of the book is $2, so that's going to be your income. $2 per book. These must be really tiny books. A book for $2? When was the last time you saw a book for $2? Oh yeah, this, I think the publishing date on this is like 2007, but even that is... Oh! Okay, yeah. Right? The little book you see by the register at Safeway? Okay, that makes more sense. So again, set up for substitution, y equals stuff, y equals stuff. So if y is stuff, I shall replace y with stuff. 2x is 0.80x plus 864. Play the Who's Lonely game, subtract. And get 1.20x is 864. That's 700 is 840, 24 to 2720. And then go back and say y is 2 by 720 is 1440. But what does it mean? 720 what? Okay, you have to sell 720 copies of the book to break even at 1,440 bucks. Okay. Okay, Sudoku books. So thinking, like, y'all remember the do they still do this? I might be showing my age here. Do they do the Scholastic Book Fair thing in elementary still? That thin little like rice paper kind of catalog, and it just shows how which kids in the class actually have money and which ones don't. I always hated it. No? Okay. Even those, I think you'd be like, you're not gonna buy a book with this. You're gonna hit up the vending machine. Yeah.
Or the little prizes you got, like those little pointers. Yeah.
So like the
Prizes?
The eraser phones. Yeah.
Oh, okay. All right.
Like the book fairs. Yeah. You guys read, but they gave us little toys.
we got like if you do it, I get to
Yep.
Do you have Jump Rope for Heart?
We had, yes, Jump Rope from Heart. That started back in the 90s. That was, I remember that.
There were erasers and kids would eat them, like actually eat them. I remember. There'd be little.
Is eating erasers just the new eating glue?
Yeah.
We still have that.
we still have that. All right. Anyway, and identifying constraints. The idea behind this is sometimes I do all the math and it turns out my answer wasn't completely reasonable. And we've run across this a few times as we're making graphs, especially in chapter 4. You remember how many of those were L graphs instead of regular cross graphs with negatives on them? And the reason for that is I can't have negative time. I can't sell negative books. Sometimes I have a constraint that might even be greater than 0, and you have to include that in your information at the end. You fill water tanks. Contains 50 gallons, filled at a rate of 10 gallons per hour. That's really slow. That's like a water faucet. That's less than a water faucet. I can fill up the big sink in like 15 minutes, 12. Even on really low pressure. Well water. Yeah. Second tank is 29 gallons right now, filled at a rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? The idea behind this would be, what if I do this and I end up with my answer is -3? Will they be the same at -3 hours? Well, no, they start at 50 and 29. That doesn't even make sense. So I would have to say they never will. Okay, that's what we mean by a constraint, is sometimes you just have to think a little bit harder than what the problem says. So I've got 2 different tanks here. Tell me, first of all, what do you want your variables to be? When will the 2 tanks have the same amount of water? Okay, they said when, so time, have the same amount of water. Well, what are they talking about in the problem? What is my amount measured in? Gallons. So which one depends on which? Does the time change and that affects how much water is in them? Or does the water change and that determines what's on the clock? Okay, so I'm going to label X and Y time and gallons. Specifically, what would my time be in? What do you think? Why? Why not minutes? It says gallons per hour. Remember when we did all that unit analysis stuff? Gallons per hour. So maybe next to this I also put H so I remember it's in hours. Okay, now I'll write my equations. So contestant 1 is the first sentence. Contains 50 gallons, is filled at a rate of 10 gallons per hour. Which format are they giving us? Slope intercept. They gave me a rate, so I know it's not standard. And they only gave me one other number instead of 2. So I know it's got to be slope intercept instead of point slope. Y is rate X plus start. Do the same thing for the next guy. The second tank. How do we write this one out? Rate X plus start. There you go. And it says, when are they going to have the same amount of water? Well, Y is my amount of water. When will they be the same? Says, when are those two going to be the same? This is called the transitive property or the substitution property in geometry, where you get to just cross out the y's and set those two equal to each other. Well, what I'm really doing is saying, y is this stuff, so replace y with that stuff. It's just a shortcut. You just cross out the y's and say this equals that. 10x plus 50 is 3x plus 29. All right, this one's got a little more oomph to it. If you remember all the way back to first semester, there's a variable and a constant on both sides. And coach says, I don't care what you do, just hit something. I don't care who you move. I don't care who you block. Just get in someone's way. Just move something. So, which one do you want to move? But which one goes first? The 10x, the 50, the 3x, the 29. Who do you want to move first? Okay. If I subtract 3x, I got 7x plus 50 is 29. Show those zeroed. Now you get the who's lonely game. The who's lonely game says 29's all by themselves. Bring them date. And you see what I mean here, where I'm doing the math right, but 7x is now negative 21. But wait a second. Divided by 7, I get x is negative 3. You go back to the beginning, and x was supposed to be time. They started with this, they started with that. I'm filling them up, and my answer tells me they're going to have the same amount of water negative 3 hours, meaning 3 hours before I started filling them. That doesn't make sense, right? So when will they have the same amount of water? They won't. Time cannot be negative. They won't be the same because time is not able to be negative. Now, if I went and kept going, okay, put negative 3 in there, got y is 3 by negative 3 plus 29 is negative 9 plus 29, y is 20. Meaning, okay, if I graph these two things, they would cross, they would intersect at negative 3, 20. Theoretically, 3 hours before I started filling them, they both had 20 gallons. But they didn't say that. They said they started with this amount. So my entire answer is just BS. It doesn't make sense in the context of the problem. So I say, they're never going to be the same. So you got to start thinking about reasonable answers. It's not enough to just do math, get answer. Does my answer make sense? In fact, the further you go, you get up to algebra 2, you start getting things called extraneous solutions. Be quiet, you. Where you do all the math right, but one of your answers breaks the laws of math. And you have to throw it out. Okay? You can date whoever you want, princess. Well, I fell in love with this guy named Romeo. Not him. Okay? So, do the same thing again. Set it up. Solve it. And when you get to the answer, what does it mean? Does it mean something that actually works? Maybe it does, I don't know. Or does it mean something that's not possible? Or how many times did we get during first semester where, say it was like the number of chairs that you could buy? Well, I can't buy 4.6 chairs, so I guess I can only buy 4 of them. So set it up and solve it. Assess your answer for how reasonable is it? Does it even make sense? Be careful, these tanks are leaking water. How does that change your equation? Mm-hmm. I'm gonna thieve my brownies and just disappear.
Of course.
Freshman.
But
Okay, same variables again. One tank contains 10 gallons of water. It's a starting amount. But if it's leaking at a rate of 2 gallons per hour, what's my rate? Negative 2x. If I start with 6 gallons of water, rate of negative 4 gallons per hour. And, just like before, if y is stuff, replace y with stuff. I should be able to say negative 4x plus 6 is negative 2x plus 10. I don't care what you move, just move something. I tried showing this first semester. Most of the kids that I had first semester weren't too happy with it. But you know you can move multiple things at once. I still added 4 to both sides. That little electric fence of doom might help you there. But if I know that that's going to zero out, then I'm going to have a 2x here. This is going to be lonely. That's going to be gone. So I could also, while I'm at it, subtract 10 from both sides. You can double dose like that. Get rid of this. Get rid of that. Either way, whether you do it in one step or two, you're going to get here. And then I go to solve, and the same weirdness happens. X is negative 2. Now, if I want to finish the problem off, I go and plug that in. Y is negative 2 by negative 2 plus 10. 4 plus 10 is 14. So negative 2, 14. What does that mean in the context of the problem?
Try to do it.
2 hours before they started leaking, or before I started measuring the leaks, they both had 14 gallons in them. Well, it didn't tell me what happened before this. It told me it's got 10 in it now, it's leaking. It's got 6 in it now, it's leaking. Now, this can be used to, it's called extrapolate. Extrapolate means you find data out past what you have. Like I could right now take just this small collection of kids and I could say, how many siblings do each of you have? And I could count that up and I could do all kinds of one variable statistics with it and then sort of apply it to the rest of the school. I could say, well, this is a decent sample size. I got like 15 kids in here, right? Those 15 should be, I mean, the kid's a kid, right? Well, what happens if this class happens to have just a lot of siblings? What happens if we got 4 kids out of our 15 that are only child? It throws the data way off. So I can extrapolate back and say, you know, 2 hours before I looked at this, they both had 14 gallons in them. Who says that they started leaking 2 hours ago? Who says that it wasn't 30 minutes before I looked at these tanks, someone came along and just poked a hole in them? Okay? So you do all the math, and it turns out time can't be negative, so they will never have the same amount of water. They might have before I looked at them, but they never will now. Okay? Round 2, wind and current problems, they're very, very common. Like, I've done several sessions of ACT review with kids this year now, and these show up on every ACT you can think of. They're just super, super common. Okay, how many of you do now or used to ride your bike to school? Do you live on a hill? You slower or faster coming home or going to school? Okay. When you're going downhill, you got gravity going with you. When you're going uphill, you got gravity working against you. It makes you either faster or slower. Well, you've been on a plane and ever hear the pilot come over? It sounds like we have a really good tailwind. We're actually going to be arriving in, New Orleans 30 minutes early. They'll say something like that, and it's because their speed is affected by that wind at their back pushing them along faster. Or maybe the current. If you've ever done a cruise, if you've ever been on a boat, okay? Any of you ever been rafting, kayaking, anything like that? The idea is whatever they're talking about, the two things you've got are your speed plus whatever the modifier is going to give you one total. Your speed minus the modifier is going to give you the other total. Make sense? Me going downhill, my speed plus gravity makes me pedal my bike at 20 miles an hour. But if I go against gravity, my speed minus gravity's effect means I'm only going about 3 miles an hour, really cranking it and huffing your way uphill. So that's the setup for these types of problems. You're going to fly from Charlotte to LA, and then back from LA to Charlotte. The airspeed is the same, meaning the engine was chugging along the same both times. But they ended up going faster one way than the other because of the jet stream. So when I went from LA to Charlotte, they had the plane speed plus the wind speed. They were going 550 miles an hour. But on the way back, the plane speed minus the wind speed, because now the wind is pushing at the plane. It's slowing it down. Okay, I know we got a couple here who are in football. The difference between you're going to go hit the sled versus you're going to go hit the sled and coach is standing on it. Okay? You have the amount of force or speed that something is doing plus or minus that modifier. Now, if you hadn't seen how it's set up, it might be a little hard to figure that out. But now that you see how it's set up, isn't this one of the easiest problems in the book? How do you solve this? Substitution or elimination? I'd do elimination. It's already set up for me. Womp. If I add each of these columns together, I get 2p is, what's that, 9, 10, 45? Divide. P is 5, 22, 5. That doesn't make sense. The wind can't be going 522 miles an hour. Did I ever define my variables? Make sure off to the side you say PW, plane speed, wind speed. Okay, does it make a little more sense that the plane is going 522 miles an hour? Okay. Then, finish it off. 522.5 plus the wind is 550. Subtract, wind is, maybe? Yep. And I should probably put some labels on there. Miles per hour versus kilometers an hour is the difference between a speeding ticket and not. Okay. Y'all notice you got regular old miles per hour if your vehicle is made in the US, and then in tiny arc underneath that, they have kilometers an hour instead. Okay. Gave my wife a heart attack years ago. I said, no, I'll make it on time. We're only doing 100. 100 miles an hour is about 65 miles an hour. It was going the speed limit. Or kilometers an hour is about, yeah. So a wind or current problem, that's what they call it, is just speed plus the modifier, speed minus the modifier, are your two different totals. The faster one and the slower one. Set them up. They'll solve nicely by elimination. You just got to finish off the problem. You're going to row your boat. How fast is the water going? All right. That one's here, that one's here, that one's here, that one's here. Gotta mark it while it's west. Wait, really? Make sure you label your variables again, too. Get in that habit now. Good habits in Algebra Half and Algebra 1 save you a big headache later on in math. Label your variables before starting anything else. Maybe I do it as RC, XY, whatever your jam is. But my rowing speed plus the current is which of these two? Right? Do I go faster or slower when I'm with the current? And then my rowing speed minus the current is the slower of the two. Get 2R is 3. R is 1.5 or 3/2. Go plug it back in. Turns out I'm not rowing very fast, but the current of that stream is moving decent clip. What about at least tubing down Spearfish Creek? Every time I go in the park, there's someone who's floating along in a tube. You at least done that? Okay,
Can you end up with 12 holes in your tube?
that too. Like, you've all been, I hope you've had some life experience, floating down the water, and then, oh crap, I just dropped my whatever. Oh crap, my hat just fell off. And then you try to like doggy paddle back really quick to go get it, and right, you can't go back upstream very well because current is pushing against you. In this case, make sure you label miles per hour. You're rowing at 1.5, but what? Oh, Jesus. See, you can't do basic arithmetic.
Okay, switch timer.
So if I have 2R plus, there we go. That's a difference. I thought it was nice and leisurely. 3.5 miles an hour, you're kind of going for it. 3.5 plus C is 5. So, got them backwards. Oops. Now the real question is, do you think you can get 20? 3 a day, you can do it. Get mean. Some days I'll just give up and say, here's your 3, leave me alone. Oof. Okay. Part B. Suppose the rowing speed is in still water is 3 miles an hour. The speed is 4 miles an hour. What happens when you try to row upstream? What do you think that means? Okay. Your rowing speed in still water. So just R is 3. They just tell me that. And the speed of the current is 4 miles per hour. Well, do exactly what we just said. R plus C, R minus C. If I'm going with the current, I'm good to go. But if I'm going against the current, what happens? You ain't going upstream. You're just gonna, like, you ever see those birds trying to fly from one tree to the other when you've got that 30-mile-an-hour wind outside? They just kind of flapping there in place, not going anywhere. Okay. Couple of you are like, same bird, same. So, you feel good about this so far? Like, they're not that bad if you have those forms? I hope. All right. I don't see a need to do more of them. Ta-da! Done. Let me go write a few problems down, and that's it. So y'all know, on Wednesday, it is an early release. So you will go 1, 2, 3 lunch here. And in here, it's a short class. The short class is 50 minutes, 51 technically. But section 6.5, 1, 2, 3, 4 examples, 5. Ooh, 5. If it was 4, I'd think would be okay.
Just start it. Actually, no, I don't want to do that.
Wednesday, early release. Y'all, it's super easy. If you know how to graph a line, literally, can you graph a line?
No work day.
This adds 2 things in. No workday. This adds 2 very simple concepts to it. So even though it's a short class, we're still going to get through everything, should get through everything on Wednesday. Okay? If not, it'll go a little bit into Friday, but those 2 go very well together.